Hello everyone, I am Dr. Arun Kumar, working as an Associate Professor in School of Civil Engineering, Vellore Institute of Technology, Chennai. Today I am going to discuss about finite element method or finite element analysis. In short, it can be denoted as FEA or FEM. Finite element method or finite element analysis is an important course for civil engineering students who wish to pursue masters or career in structural engineering. Finite element method or finite element analysis is also an important course for research and development in engineering, science and technology. In this presentation, I will be highlighting the complete modules covered under finite element method. I shall also discuss about the references in the textbooks that is involved in this course, and I'll also highlight the introduction to FEM, what is FEM, background and history of the evolution of finite element method. Finally, types of finite element analysis. Let us see the different modules attached to finite element method. The first module will be the introduction to finite element method, followed by principles of elasticity. The third module will be theory of finite element methods, followed by one-dimensional, two-dimensional and three-dimensional finite element method. And it is followed by natural coordinate system and finally isoparametric formulations. Finite element method or finite element analysis can be used to analyze man-made structures like building, bridges, automobiles, etc. It is also used to analyze the natural phenomenon like the effect of earthquake on the building or the structures. It is not only used to analyze how the structure or a building behaves under the force, but also the effects of vibration, heat, fluid flow and other physical effects. Recently, the effect of transmission of COVID-19 through coughing and sneezing have also been analyzed using finite element method. For any course, the references and the textbooks that is to be referred have to be highlighted. So these are the references for textbooks and reference books. Now let us see the introduction to finite element analysis. But before that, I should define what is finite element analysis. Finite element method or FEM can be simply defined as a numerical technique used for performing finite element analysis of any given physical phenomenon. To introduce the finite element method, it is a numerical technique as already explained to find an approximate solution by using partial differential equations. It was actually originated to solve complex elastic and structural analysis problem in civil, mechanical and aerospace engineering. Finite element method use structural simulation that helps in producing stiffness and strength visualizations. The main use of finite element method is to minimize material weight and cost effectiveness of the structure even before constructing or designing the actual structure. It also allows a detailed visualization and indicates the distribution of the stresses and strains inside the body. So the stresses and the strains are the most important factor that affects the equilibrium or stability of any material or the structure. In finite element analysis, all the complex problems such as varying shapes, boundary conditions and loads are maintained, but the solutions obtained are approximate. It can be made to accurate solution by using the software tools by repeating the number of iterations. Many finite element software are powerful, but it is complex. But yet, this can be used by a professional by using training and education to interpret the results. Several modern finite element method packages include specific components such as fluid, thermal, electromagnetic and structural environments. The main advantages of finite element method allows entire designs to be constructed, refined and optimized before the design is manufactured. It also has a significant in decreasing the time to take the products from the concepts to the production line. Few commercially available finite element analysis software packages includes StatPro, ANSYS, Autodesk, CFD, COMSOL, MATLAB, Abacus, Adina, LS Diana. These are mainly used by engineers to analyze the complex structures. Before discussing in detail about finite element method or finite element analysis, let us see the background and the descriptions of the finite element method. The history of finite element analysis can be traced back to the work by Alexander Renkov and Richard Courant in 1942 and 1942. Renkov introduced the framework method in which a plain elastic medium was represented as a collections of bars and beams. Both of these pioneers, Alexander and Richard, shared one essential characteristics, that is mesh discretization of continuous domain into a set of discrete subdomains, usually called as elements. Later in 1950, the solution of large number of simultaneous equations made possible because of the digital computer. In 1960, Ray W. Clough first published a paper using the term finite element method. In 1965, the first conference on finite element analysis was held. Later, in 1967, the first book on finite element method was published by Zenkiewicz and Chung. But in late 1960s and the early 1970s, the finite element method was applied to a wide variety of engineering problems. In the late 1970s, most commercial finite element method software packages are Abacus, Nastran, ANSYS, etc. Even today's date, Abacus and ANSYS were used for most of the complex engineering problems. These finite element programs were highly interactive on supercomputer that leads to rapid growth of CAD systems. There are several applications of finite element analysis or finite element method. Starts with fluid flow in structural interactions. Biomechanics related problem with higher level of accuracy were also observed in this decade. In the 1980s, algorithm on electromagnetic applications, fluid flow and thermal analysis were developed with the use of finite element program. Later in 1990s, engineers evaluated the ways and different methods to control the vibration and extend the use of flexible, deployable structures in space using finite element analysis and other methods in 1990s. With the development of a tremendous increase in the computing power and convenience, today finite element analysis can be used to understand the structural behavior with high level of accuracy. This was a way beyond imagination before the computer age. In civil engineering context, FEA was originally originated as a method of stress analysis in the design of aircrafts. It started as an extension of a matrix method of structural analysis, but today even in the analysis of fluid flow, heat transfer, electric and magnetic fields and many other applications have evolved by using computers. As we all know that the formulation of structural analysis is generally based on three fundamental relations such as equilibrium, constitutive equations and compatibility conditions. And for analyzing any structure, the two major approaches are analytical and numerical. The analytical approach begins with closed form solution that is effective in case of simple geometry, boundary conditions, loading and material properties. However, in reality such simple cases may not exist. As a result, various numerical methods are evolved for solving such problems which are complex in the future. The numerical approach identifies and approximate solutions which are approximately satisfied. It heavily depends on the processing power of the computers and it can be applicable to the structure of arbitrary size and complexity. Few numerical methods which are commonly used to solve solid and fluid mechanical problems are given below. The first one is finite difference method, followed by finite volume method, finite element method, boundary element method, meshless method. In engineering problems, there are basic unknowns such as displacement in solid mechanics, velocities in fluid mechanics, electric and magnetic potential in electrical engineering, temperature in heat flow problems. If these unknowns are evaluated or found, the behavior of the entire structures can be predicted.